Not long notes, not long homework at all. But this is not one of those lessons that you can kind of half listen to, because the one thing that you could get confused about with this is the notation. So I need you guys to really pay attention while I'm going over the notation. Other than that, it's very, very simple. If you just get this one little concept, it's cake, okay? Don't forget, the quiz opens tomorrow. So we'll finish up 2.8 today. The 3 of you that were absent yesterday, you should watch the video. Make sure you're up to date on the first part of 2.8. Tomorrow is one day of 2.9. Quiz is on those 2 sections. Open for a full week. Friday is a work day, so you can work on it in class if you're here and so inclined to work on it in class. So I'm giving you a day to work on it. And then the progress check closes tomorrow night at 11:45. So don't forget about that if you didn't do it in class last Friday or whatever. Okay? All right. So we're continuing with the word, with this concept of inverse. Okay? So if we have 2 functions called f and g, so there's a function f and a function g, and they are inverses of each other. Okay? Then g of x could be considered the inverse of f of x. So again, this is about notation, right? If these 2 are inverses of each other, you could say g of x is this symbol. We learned this little notation yesterday to mean inverse. So that's kind of interchangeable if that was put in the directions. I'll show you what I mean in a second, because our first one is. So here's some basic stuff we need to know about inverses. If x and y is a point on the graph of f of x, okay, then y comma x is a point on the graph of g of x. And remember, g of x is just an inverse, okay? Just another way of saying the inverse of f in this example, okay? So what I want you guys to have in your brain is inverse means switch x and y in all forms, every single form. And I'll keep pointing that out. And here's one of those. With inverse functions, all of the x and y values are switched, right? All of them, whether it's in a table, a graph, an equation. So on a graph, the graphical behaviors in terms of x and y will also be switched. A point on f of x, called xy, would be switched on its inverse. Switch x and y. So here's another really new concept. Not new, but add on to what we've been saying. The domain of f is the range of f inverse of x, also known as g of x, right, in this example. So domain means x values. Range means y values. So if you know the domain and range of f of x, all you would do is flip them for the inverse. The domain becomes the range becomes the domain. Everything is, you just keep remembering that I say x and y switch. Lastly, a continuous function, I'll come back to that, will only have an inverse function if it is strictly increasing or decreasing. Guys, this is a continuous function. That's called a line. This is a continuous function. It's called a parabola. This is a continuous function. It's called an exponential function. Continuous means there's no holes. It doesn't like stop and jump over something. It goes on forever and ever. It's continuous, okay? So remember, this is important, the language of this. Every single relation, we learned that word relation yesterday, is just a set of ordered pairs. Those are relations, that's a relation, an equation is a relation. All relations have an inverse relation. Okay, you can switch x and y in any table of values, any graph, any equation, right? It's mechanics. You just switch them, all right? But is the inverse a function? Okay, so that's the difference. So relation's just general term. Function's very specific. No repeat x values, okay? So a continuous function will only have an inverse function if it is strictly increasing or decreasing. That's a line is strictly increasing or decreasing. A exponential, there's no min or max. It doesn't turn ever. It's always going to be going up, left, or right, or it could be decreasing. Same with the lines, always increasing or always decreasing. This one is not always increasing or decreasing, right? It's, in this example, a parabola is decreasing till it gets to its vertex, which in this case is the minimum, and then it switches. It's increasing and decreasing on the same graph. It has a turning point. So when you switch the x's and y's on a graph like this, it won't be a function. Okay? You can find its inverse relation, but it wouldn't be a function because the inverse of this guy would look like this. trust me, I'm not going to make us do it, but if we took all the points on any parabola, whether it opens up or down, flip them, it would open to the sides, okay? So what this next thing is saying is it will not pass the horizontal line test, and its inverse relation will not pass the vertical line test. So what we're saying here is, you might remember we talked about the vertical line test yesterday. All of these pass the vertical line test. They're all functions. If you flip this one, it'll still pass the vertical line test. This one doesn't. See how here the vertical line test hits 2 of the x's. Horizontal line test is a quicker way of saying, because remember, vertical is like y, horizontal is x, other way around. They're opposites of each other. If you do the horizontal line test on the f of x's, you can tell if when you flip them, they would pass it or not. So when I do a horizontal line test on a line or an exponential function, I will never touch the graph more than once. But clearly, if I do a horizontal line test on a parabola, it fails. That tells you that when you flip it, it would not pass the vertical line test. So there's 2 different tests, okay? So that's what that was talking about, right? Now, here's where I'm going to go really over this notation. You have a table of values here, right? X and Y called f of x. F is a continuous function with selected values in the table below, okay? G is the inverse. So remember how they said up there, if they tell you in the directions to call it something other than f inverse of x, then you have to pay attention to that. So understand, in this example, g of x is the inverse of f. G of x is this table flipped. Yesterday, you had a question, 2 questions in your homework, embarrassingly, because it was too easy for you guys, where you had to flip that. I'm going to write this over here. I would rather you not, because I don't want you to ever have to do this. I want to make a point, though. Yesterday, we learned that if I wanted you to find the inverse of this, you go, oh, flip x and y, okay? And we're calling it g of x. So this is what one of your answers was. And I'm not going to lie. There's a question on your quiz where it's A, B, C, or D. Which one of these matches up to the inverse of the f of x? So you would just choose which one has that, right? So I could easily say, here's f of x, flip it, now that's g of x, right? I don't want you to have to do that. So watch what we're going to do. We're going to do some, and I'll come back to why I did that, I promise. I'm trying to hurry for the sophomores. Notice the notation. This is all about understanding the language of this class. Remember, we work right to left. This is composition of functions. We should see that and know, oh yeah, that's right, we do plug this into this. We did some of it yesterday too. Guys, this is x, right? How many times have we done this? This was on our last test. So f of 0, that means I'm going to go to the f function to where x is 0 and get my y value, right? F of 0 is 1, right? So now I would do f of 1. So I got 1 here, plugging it into the f function. Again, f of x, that just means that is x. F of 1. So I go right here. When x is 1, y is negative 1. Right? Nothing new. That question could have been on your most recent test. Right? Now, what does it mean when it says g of x? Well, if you went to the trouble, so this is the moment, so pay attention. If you went to the trouble of doing what I did over here, notice I didn't put it in the notes because I don't want you to have to do this. I would say, oh, that's the input of the g function, right? I would go to this and I would say, okay, the input of the g function is -3, so my answer would be 4. Instead of doing that, every chance you get, switch x and y. So instead of this being x, because it's the inverse, this is actually y of this graph.
Good morning, Countryside family. Teachers, at this time, if you will please release your sophomore students.
Sophomores, don't forget your phones. Take your stuff. I don't think they'll be back. You're going to have to watch the video, though. I'm sorry. They're trying to sell you class rings, I'm pretty sure. It's a fundraiser for the school. Let's take kids out of class for that. Makes me so mad. Guys, you can buy a class ring if you want to, but you can buy them from other companies a lot cheaper than that one. And I'm recording myself saying this. I shouldn't do that, but... Okay. Stanley, just give it to me. I'll fix it for you, sweetie. That way you can go. Just put it right here. Thank you. Guys, watch the video. All right, so do you guys see what I did there? Like, you could switch this and have a whole new table of values to use, then that would be x. But let's not do that. Let's just know that that's normally x, but this is inverse. Inverse means switch x and y. So if I normally call that x, now I'm going to call it y. Okay, here's another one. So G is our inverse. That means this is y. So in this table, just think of it as split, okay? But in this table, we would go to y is 6, x is negative 3. Okay? Remember, G is the inverse. So instead of this being x like it has been for the last 1,000 years of your life, with inverse, we switch x and y. So y is negative 1. Let me switch up my colors here. Y is negative 1, right? So x is 1. Same thing again. G is the inverse. So knowing that, because it told us that in the directions, this is y of this table. My final answer would be what? 0. So let's mix them all up together. This is still the same notation, right? This is f, inverse of f, still right to left. Start right here. Guys, f is just a regular old function. That's x. So when x is negative 2, y is 3, right? F of negative 2 is 3. Now what you want? Oh, okay, you're switching back to the other notation. Fine, we can handle that. That means, that means inverse. So now we're talking about y. Are you guys seeing what I'm doing here? Is this making sense? If you don't like it, you could flip your table and then go back to calling these always the x, this would be x of this. But my keys aren't going to show it like that, and I really don't feel like you should have to do that, okay? And this whole lesson is that, so hopefully if you're even a little bit confused right now, in a few minutes, by the time we finish this, I think you'll have it. This symbol means inverse. That means instead of this input being x, it's y. So y is negative 3, x is 4. You're just switching it, okay? In example 2, and I know there's a question on your quiz just like this. The function k is defined over the interval of negative 4 to 11. It's just saying the domain of this graph is negative 4 to 11. That's what it's saying, right? Inverse of k, so they're using that symbol. We know now that that means inverse, represents the inverse of k, even says it. And they're going to ask us some questions. So the first one is, what is the minimum value of k of x? Guys, minimum value. Let's review what that means. Min value is the smallest y value, okay? So what is the smallest y value of k of x? Here's k of x. So look at your y-axis. What's the smallest y value that we use? Negative 3, right? That's the minimum value. Where does it happen? At negative 4. But when it's asking for minimum or maximum value, it is the y. It's the second part of your ordered pair, the y value, okay? So that's just a review of something we should know. What is the minimum value of the inverse? Okay, so this was of k of x, right? Minimum value of k of x would be the smallest y value. What would be the minimum value of the inverse? Remember what I said, guys. If you have to do something with inverse, you switch x and y. So what do you think I would say this is? It's the smallest what? X value. You switch x and y. Any way you are given an x or a y for the function, you just change that word, that position, whatever it is, to the other word. Okay? Smallest y value, oh, we're going to switch it to smallest x value. Switch x and y. So what is the minimum value of the inverse? Okay, so it's normally smallest y value, so I need the smallest x value. So look at my x-axis. What's the smallest one I use? Negative 4. And again, this part B is exactly what we were doing up in the example 1, but instead of looking at a table of values, we look at a graph. So we know that this symbol means inverse. So this is a y value. This is a y value. What this is asking is, what is the value of x when y is 6? So go to your y-axis to positive 6. Here it is. Look left, look right till you find a point. Here's one. That point is 11, 6. Right? So when y is 6, x is 11. Go to your graph. When y is positive 4, that's right here. Look left, look right so you can find a point. There it is. That point is 6, 4. Right? 6, 4. So when y is 4, x is 6. And just flipping. We getting it? Yep. Okay, keep going. There's another one. Graph of f from negative 2 to 8. Let inverse of f represent the inverse of f. What's the maximum value of the inverse? Remember, guys, maximum value of f is the largest y value. This would be the largest x value. You just switch x and y. So look at your x-axis. What's the biggest number we use on the x-axis on this graph? 8. Right? That's the biggest x value we use on this whole graph. The notation is telling us this is y. It's been x for our whole lives until this moment. Right? How many times have I said, whatever you see in parentheses is the x value. Plug in for x, plug in for x, plug in for x. Well, now it's the inverse, so we switch x and y. We're plugging in for y. So, when y is 3, x is 2. Okay. When y is 1, x is 3. It's really about knowing the notation. The math isn't hard. You don't need a calculator for this. No work to show. Not adding, subtracting, not doing anything. You're just understanding the notation. Okay, domain, what does domain mean on a graph? All the x values. So if they want the domain of f of x, just f of x, this graph we would name the x's, which is negative 2 to 8. But they want the domain of the inverse. So that's really the range of f of x, right? It's the range of f of x. Switching x's and y's, okay? So let me, in case anyone is confused, let me just make sure you understand that. F of x, not the inverse. My domain is from negative 2 to 8, right? Those are the x values I use. And my range is from negative 3 to 7, right? So if I needed the domain or range of f of x, there it is. I want the domain or range of the inverse. You flip them. You just flip them. Because domain means x's and range means y's. And we know that inverse is flipping the x's and y's. Right? You don't have to write all that, but that kind of helped last period. Some people seemed a little confused by that. Okay? So the range of f of x is the domain of the inverse. Okay? All right, they're going to try and confuse us down here. Our last example, we're not going to let it happen. This is where it is really important. Sometimes, and I'm bad about it too. I don't like to read directions. I don't like to read a whole word problem. I just want to get to it. But you just want to be careful, make sure you understand what they're giving you. Function g, so here's a graph of g from negative 3 to 10. And then, of course, there's going to be an inverse of g. Now, they're calling it g to the negative 1, so that regular notation. And then we have h of x, and we might, I'm sure, get thrown some inverses of h of x. So what I'm getting at, guys, is way at the beginning of the lesson, I talked about let g of x be the inverse of f of x. That's a specific example. Like, they told us that right here, okay? They said let g be the inverse of f, okay? So they're telling us g of x just calling it something else other than using that notation. So be careful. It doesn't mean that always and forever now g of x is some inverse of f. It would have to be given to you like that, okay? All right, so notice no weird notation here. No -1 or anything like that. This is traditional, boring old x. So when x is 6 on the, h of x, make sure you got the right graph. That's my input, right here. When x is 6, y is 10. So I would have g of 10. Still no weird notation. Just go to the g function. That means this is x again. So when x is 10, y is -1. Right? Hopefully you guys are writing this down. Some of you don't look like you are. H of 0. No weird notation. That's x. Go to h. X is 0. Y is 3. Right? H of 0 is 3. Weird notation, inverse. Instead of this being x, this is y. So go to the g function where y is 3. Look left, look right. There it is. When y is 3, x is 4. So they can mix them together. Regular notation, x. When g is 8, g of x is 8 on the g graph, y is what? 0. Inverse notation, that means instead of this being x, it's y. Go to the h. When y is 0, x is -1. Last one, inverse. So this is y on the g function. So when y is -1, x is 10, right? That point is 10, -1. So when y is -1, x is 10. Inverse notation means this is y. In the h, you just have to just follow where you're supposed to go. Go to the h, y is 10, x is 6. And you'll have one in the homework where they ask you for a number that doesn't exist, okay? So if they said, what is inverse h of 20? There is no 20. You would write DNE, like does not exist, or undefined, something like that. You'll see it in the homework that you will finish in class without a problem. So if I went too fast over any of it, it's hot in here. If I went too fast over any of it, or you have questions or anything, please, this is no one's here. There's enough of me to go around. I'll put the key up, but please ask for help if you don't understand anything from today or yesterday. Okay. And I think you can just turn the page a few and find worksheet B15. I'm just doing all of it. And I can fit it all up here, but I will put it on Canvas as well.